2, we have y double prime plus 4y prime, or sorry, y double prime plus 4y equals cosine 3t. So step 1, we look at the homogeneous equation, y double prime h plus 4yh equals 0. This has a characteristic equation, lambda squared plus 4 equals 0, which gives us lambda equals plus or minus 2i. Our homogeneous solution then is c1 cosine 2t plus c2 sine 2t. And now we find the particular solution, and we do that by looking at our forcing term, which is cosine 3t. Since we have a cosine with a angular frequency 3, our particular solution is going to be a cosine 3t plus b sine 3t. Now we go ahead and find the second derivative. We have to first find the first derivative, which is negative 3a sine 3t plus 3b cosine 3t. And then our second derivative, y double prime of p, is going to be negative 9a cosine 3t minus 9b sine 3t. Now we plug yp into our inhomogeneous equation. This gives us negative 9a cosine 3t minus 9b sine 3t plus 4a cosine 3t plus b sine 3t equals cosine 3t. Simplifying this, we get if we combine the cosines together, we get 5a cosine 3t, or negative 5a cosine 3t, and negative 5b sine 3t. If we combine the signs, this equals cosine 3t. So since the coefficients of the cosine terms on both sides need to be equal, 5a must equal 1. And since the sine terms on both sides need to be equal, we have 0 sine on this side, we need negative 5b to equal 0. So this gives us b equals 0 and a equals negative 1/5. So our particular solution is negative 1/5 cosine 3t. So our complete solution, yt, which is yh plus yp, is going to equal c1 cosine 2t plus c2 sine 2t minus 1/5 cosine 3t.